Okay, so in this chapter, we're going to look at when we have interest-only loans. So this is when you only pay the interest off, so the interest earned. Okay, so if you think about it, so your loan amount, it will never change. So say you're going to make monthly payments. So in the first month, you'll earn so much interest, and then that is all you're going to pay. So your payment only pays what, it's charging you, and then you're left with the same amount that's owing. So then the next monthly payment will be exactly the same. So what you can see, we've got an amortization, there's sort of got a recurrence relation going on there. And you can see, so the interest charged is going to be the payment, like the minusing. So it'll be exactly the same. Now, why do we do this? Why would people do this? And when you're buying, so a lot of people, when they're buying investments, say an investment property, so you go buy the house, the house is going to sell, for a lot more in, say, 10 years' time. So there's no point paying it off. You're just going to pay, you just don't have the original principal. So you borrow that from the bank, and they say, well, there's a cost to that. So you pay the interest, you will eventually sell it off, and you will sell it for a lot more than you bought it for. So that's how you'll make your money. So this is what interest-only loans. Sometimes too, when obviously, and you'll hear about times like now when interest rates get too high, and some situations have changed. Someone might have lost their job. They'll change to, they'll work out with the bank, can I just pay the interest now? Because that's all I can do at the moment. And then you just keep going. And then when you get back on track, you go back to changing it. So what you can see, so down here is a scenario or the summary of a recurrence relation. So remember, we often get asked to do, to write recurrence relations. So it will look the same as a reducing balance loan. But what happens is the amount that it's gained is going to be so the amount of interest will be the same as that D, that payment. So if you want to maybe write, you might want to write a little thing that D equals the amount of interest to earn each period, yeah? Because we might need to, we'll use that, maybe the D formula to calculate something. So you can see too, they are mentioning VO. So in our banking situations, VO is the same as PV, okay? So when we put into Finance Solver with an interest-only loan, because I told you the value of your loan never changes with an interest only. So whatever you borrowed will be the same amount you owe after, it doesn't matter how many periods, because you're only ever. So what you'll see there is that the FV is the same as the PV. So on Finance Solver, when it's an interest-only loan, PV will be positive because you're borrowing money. Your FV will be the exact same number, but it'll be negative because you still owe it. Okay, so Jane borrows $50,000 to buy some shares. So because she borrows, that's a loan. So we're going to say PV is positive. So this is another, people use it, interest-only loans to get shares because they know within a few, in a week's time, they might have an insight. They know these shares are going to triple. So they get a loan, they buy the shares, they'll say, I'll pay the interest for a week. And then they sell the shares and then they make the money, okay? It's because they don't physically have that money to buy them, so they get a loan for it. So anyway, Jane borrows $50,000 to buy some shares. She negotiates an interest-only loan. So they will be telling you when it's an interest-only scenario. So you'll know you can go to your summary sheet and go to this situation. And it's an interest rate of 9% per annum, so that's our I. Compounding monthly, so PPY equals 12. And what is the monthly amount Jane will be required to pay? So pretty much in Finance Solver, that's the payment is the question. And also, if you were looking at your recurrence relation, it's the D value. So we were just going to go and use, so I'm going to first do solving it using the formula. So I'm going to write here, so D equals the payment, and we have the formula for D. If you look, it's the rate over PPY over 100 times VO. So in this scenario, if I went and did that, it would have been 9 over 12 over 100 times 50,000, and we end up with, so her the interest that she pays is 375. So that would be me using the formula, but you can use Finance Solver. So I'm going to write down here, so, and we've got the screen dump there. So Finance Solver, so you can see we would pop in N. Now, when it's interest only, because it's the same amount every time in terms of, because we never change the payment, you can just get away with putting N as 1. You just find out what one period is. So we put in the interest, 9. Now the PV, she borrowed, so it was a positive 50,000. Payment is going to be my question. Now FV, in an interest only, means I still owe the same amount after one. It doesn't matter how many periods, you'd still owe the same amount. And PPY in this case was 12. So you can see I popped it in the Finance Solver, and you guys can see that. And the payment, you can see the payment says negative 375 because we know a payment, if you have to pay the bank, it's negative. So can you see how those two numbers matched? That was two ways I did it. Yeah, I showed it with the formula, or you can use Finance Solver, whichever. This is not in the question, but we're just going to do it as a side note. If I was writing a recurrence relation for this, because this is what you often get asked, if I had to write a recurrence relation for this scenario, I would have VO equals 50,000, and then I'd have to have my VN plus 1 rule. So it would be, so remember you have to calculate the R, which I'll just do here. So R would be 1 plus the rate over PPY over 100. So it'd be 1 plus, what was it, 9 over 12 over 100. So that equals, all right, so that would end up being 10075. So if you were writing a recurrence relation, that would be your R, and then you write VN, and then you minus the payment, which is minus 375, okay? So there's a recurrence relation of that scenario. So you can follow your formulas, go to simple interest, and it would have showed you how to do that. Okay, let's do this next one. It says a loan of 6% per annum, so that was I, compounding monthly, PPY equals 12, and requires a payment. So this is of 440. So you're going to make a payment. So that's a negative payment because it's a loan, and that's also your D value if you like. So each month, if the loan is an interest only, so they're telling me the interest only, what is the principal? So remember what I said, that the principal, which is also PV, is also VO. So you probably need to make a note when it's interest only, and you're finding the PV, you need to use the formula. The formula for, and it's D. So you can't use Finance Solver in this case. Why? Because Finance Solver, you need to only have one thing missing, and in this case you have PV and FV missing because they're the same. So what you've got to do is use that D formula. So what I'm talking about is what we used before. We used this to find what the payment is. Now I've been told the payment, I know that's 440. I know the interest rate is 6. I know PPY is 12. So the VO is the only thing I don't know. So I might just chuck X there and we'll just use solve, comma X, and we end up with X equals 88,000. So now I can just write there for the principal, because that's what VO is, PV equals 88,000. I couldn't use Finance Solver, and just to show you, because if you wrote out your everything that you need for your Finance Solver, like that, PPY, sorry. If you look, you actually have, well, you can do this, you can do the interest, you've got the payment, and you know that. But because there's two things missing, you can't do it, yeah? We can't find PV because FV is the same as PV. That's all we know. So that's why when you might get to that stage and go, whoops, I've got to use the formula. Okay, so we've got an interest only. So once again, they're going to tell you interest only of a loan of 1 million. So remember, that's a positive PV. It requires quarterly payments. So you got told PPY was 4 there. And the payments of 4,000. So that's a negative payment they told me there. Okay, what is the annual interest rate of the loan? So that is, I is the question. So we just got to use Finance Solver, and because that's obviously always our quickest bet. So let's go through what we know. So when you're trying to find the annual interest rate, or the I, and when you have interest only loan, we can just chuck 1. It doesn't matter, you could put 1 and 100 because the payment is always goes back to the same thing. It doesn't matter, you'll get it. So I is my question, so I'll leave that. Now my PV, because you borrowed 1 million, that's positive. Payment was negative 4,000, and FV is my PV but negative. Because out of an interest-only loan, it doesn't matter how long you go for, you're still going to owe the same amount. So I'll still owe $1 million, and PPY is 4. So we would have put a thing on that, and we end up with 1.6%. So we're going to say the annual interest rate is 1.6% per annum. Okay, so in this exam, Shirley would like to purchase a new home. She establishes a loan for $225,000. So I got given a PV there. Interest is charged at a rate of 3.6% per annum. So there was my I, compounding monthly, PPY equals 12. Now, each month, Shirley will only pay the interest charge. So when they told you that, that's their way of saying interest only. Okay? So you now know this is an interest only loan. Okay, after 3 years, so if it's an interest only loan, after 3 years, the amount Shirley will owe is, you don't have to calculate anything. What is it? I just said before. Yeah, the amount you owe never changes. So what does she owe after 3 years? It's the what? C, yeah, 225. It's always going to be this. You're never paying any of the actual loan off. You're only just paying interest. Okay, so then the next one, it says, let VN be the value of Shirley's loan after N months. So that's all right. We said PPY was 12. And write a recurrence relation. So here's again where I told you. First of all, you probably need to calculate the R, which if you go to your formula sheet, this will be the R value. So it's 1 plus 3.6 was per annum divided by 12 divided by 100. So we get an R value of 1.003. We also need to work out the D value, which was the similar PPY over 100 times VO. So it'll be that 3.6 over 12 over 100 times the 225,000, and we end up with 675. So when I go to write the recurrence relation, I need VO, which is 22500. So they all have that, so I can't even eliminate. And then Vn plus 1 will be your R value times Vn, and then minus your payment. So which answer is that? It is D.